name is Stephen, and my presentation is going to be a short summary of a short history of nearly everything that's this book. It's really good. I don't know if y'all heard of Bill Bryson. He's pretty hilarious. Anyway, yeah, it goes through basically the progression of how we got our science. So, yeah. A few points. All quotes are Bryson's, unless noted otherwise. This basically turned into just a compilation of the strangeness of the scientists we grew up knowing. So forgive me if it's more entertaining than most history that you've experienced. Lots of quotes, but stick with me, they're worth it. Okay. So here's about the author. He dropped out of school to go backpacking in Europe. It's pretty sweet. He's known for his cynicism and satire, which tickles my heartstrings because it's hilarious. And he holds a dual citizenship in the US and Great Britain. Pretty sweet. Okay. So here's the Sombrero Galaxy. Pretty sweet. First quote, space is enormous. The average distance between stars out there is 20 million miles. And of course it's possible that alien beings traveled billions of miles to amuse themselves by frightening the daylights of some poor guy in a pickup truck in Arizona. They must have teenagers, but it does seem unlikely, so thank you, Bryson. So this is the second part of the book, the size of the Earth, and he kind of zooms in on Newton and just kind of expounds on how strange this guy really was. He was a decidedly odd figure, brilliant beyond measure, but solitary, joyless, famously distracted, and capable of the most riveting strangeness. There is an account of when he would wake up and swing his feet out of bed, and then just get completely incapacitated with a rush of thoughts and just sit there for hours thinking, like motion stock still. Here's another one. He once inserted a long sewing needle into his eye socket and rubbed it around. This is Newton speaking, as near to the backside of my eye as I could, just to see what would happen. I don't think anything happened. Next. Here's a better looking picture of Newton. He didn't like 1600s math, so he invented his own, the one we all know and hate, love, calculus. And then he didn't tell anyone about it for 27 years. Okay. Next. So I think we all know this one from electromagnetism, gravitational, whatever. He was talking to Dr. Edmund Halley, the namesake of the Halley Comet, and he told Halley that he had derived this equation, and Halley was like, "That's great. Where are the papers?" Go to the next quote. "Why, saith he, I have calculated it." Whereupon Dr. Halley asked him for his calculation without further delay. Sir Isaac looked among his papers, but could not find it. So if you ever feel disheveled or distracted or losing papers, so was Isaac Newton. Okay. Here's another scientist, Carl Wilhelm Scheele. Pretty cool guy. He discovered all those elements. And you might say, well, that's pretty normal. Like, what's the strangeness about this? He showed a curious insistence on tasting a little bit of the chemicals that he discovered, including mercury. And then he died. He was actually discovered in his lab, dead because of mercury. Okay. Einstein. So we all know this equation. You can go to the next one. We all know this equation, but do we know what it means? Like, this equation is insane. The speed of light is a massive number. It's like 300 million or something like that. And it's squared in this equation, which means, go to the next, which means the amount of energy inside mass is massive. Bryson says, if you're an average sized adult, you will contain within your modest frame no less than 7 times 10 to the 18 joules of potential energy, enough to explode with the force of 30 very large hydrogen bombs. That's what this equation says. So that's how radiation works. That's why radiation is such a good form of energy, because it's constantly releasing just a little bit of this massive amount of potential energy within mass. So pretty cool, okay. Here's dodo birds. Let's talk about these a little bit. Another chapter later on in the book, he goes through how dodo birds were made extinct. They existed on this island near Madagascar, and some bored sailors finished them off for entertainment. This was in the 1700s. Really sad. Okay. And Bryson says millions of years of peaceful isolation on this island didn't prepare them for the erratic and deeply unnerving behavior of human beings. And then another story, a few years, like maybe 60 or 70 years after we think they went extinct, there was a curator in a museum who, for some reason, was having a bonfire, and the curator found the stuffed specimen of a dodo bird, and he tossed it in the bonfire because it smelled bad. Well, it turns out that was the last actual record of dodo birds. So we don't know, if we go back, so we don't really know what a dodo birds look like. These are just kind of artistic renderings because the curator guy tossed the last one in the bonfire for this museum. Anyway, so some points on space miles. Bryson questions the confidence that we put on, this galaxy is 60,000 light years away. He says when astronomers say the galaxy M87 is 60 million light years away, what they really mean, but don't often stress to the general public, is that it's somewhere between 40 million and 90 million light years away. Okay? So why are we so uncertain? And a better question might be, why are scientists so solid, but really so unsure? I don't know the answer to that one. But for the next slide, say we have two lights in a dark field. One is a little bit darker than the other, and we're trying to find the distance between these two lights from the lights to us. We might be able to say, the dimmer one is further away because it's dimmer, duh. But then we say, okay, well, what is the wattage of these bulbs? How do you know that one is in 100 watts and the other 60 watts? The same bulb exists in space. How do we know that stars that are dimmer aren't just dimmer because they're less powerful or smaller? Another thing is, what if there's like a dust storm in the middle of the field? How do we know that one light isn't passing through dust, and the same goes for cosmic dust? So that is the kind of the reason for all this uncertainty and estimations. Okay. So then, in conclusion, the consistent theme is that the studies and scientists that we see as kind of immutable, and these figures and concrete and time, they were just kind of figuring things out as we are. And then Bryson says, of genetic research. You can trust the studies well enough, generally speaking. What you can't trust are the sweeping conclusions that people often attach to them. And then the last one, the fact is, we don't know, we don't have any idea. We don't know when we started doing many of the things we've done. We don't know what we are doing right now. And the last point, what we do know is that there's only one planet to do it on, and only one species of being capable of making a considered difference. So in conclusion, we're all figuring things out on our own,